Alright, hey guys, sorry we ran into like the end of the class, last class. Yeah, we need to we need time to finish the quiz, obviously. Okay, so before I start, I'll start with a joke. Why did the polynomial plant wilt? Or why did the polynomial plant die? Because the roots were imaginary. Get it? Alright, so what we're going to deal with today is polynomials, but we're going to look for real roots. What that means is we're finding real zeros. So there's two things that mainly get covered in this section. We're going to probably do this again next class, but this is kind of like front-loading our lesson, and hopefully we can do like one or two questions. Okay, so midway between the video, I'm going to tell you guys what the questions are on our homework, and I'll show you what they are. I just need you guys to do probably like 3 or 4 problems, but mostly just watch this and try to have questions to ask. Alright, and whenever you're confused, just go back and watch it again. So what we're going to look at here is zeros and real roots. So I'm actually going to pull up something like Desmos. So let's pull up Desmos. Sorry, I'm using all caps so you guys can see. So essentially, some of you guys are still struggling with the idea that there's you know, any even degree power is going to be like this, right? Any even degree power is going to be like this, or it's going to be like this. Whereas an odd degree power is going to be, I guess from your perspective, it would be like this or like this. So we can even look at that on here. I'm going to show you that from here. Okay, if I have a x, right, let's go y equals 1x. That's a line, right? How many zeros are there? Just one. Right? Let's do y equals x squared. Now that's an even degree, right? Remember that this is an odd degree. And for this even degree, we can see that we have 1 0 right now, but I could make this, let's go minus 100, minus 20. I could make this 2 zeros. So at most the line has 1 0, or 1 root. For a degree 2, a quadratic, you have 2 possible roots, right? Demonstrated right here. For a degree 3 polynomial, like x to the 3rd power, x to the 3rd power, and you can even put in like 100x if you wanted to. Or let's do like plus 5x minus 7, right? Or let's do x squared. Okay, now when we look at this green one, this is an odd degree, right? It's favoring the odd degree, and we know that the M behavior, because it's an odd, is no matter what, if I go towards the positive, this is always going to be the strongest, right? That's why we worry about the degree. We think about the degree, and it's that if you're positive, it's going to end up going positive, right? As you get bigger, the inside stuff, you know, that could change based on like this. But at most, we're going to have 1, 2, 3 zeros. Right? For the quadratic, we had at most 2 zeros. For the cubic, we have at most 1, 2, 3 zeros. And the M behavior is going to be like this and this, because it's, if I'm going positive and I plug in a positive number, I will get a positive back. If I go negative and I plug in a negative, I will get a negative back. And it's mostly because the strongest term here, if I put in an infinity, where I put in like a million, like this is going to be the one that carries all the weight, whereas this one's not going to carry as much, and this is going to be like insignificant. Okay, so let's imagine what a 4th power would do. Let's go x to the power of 4 plus 3x cubed plus 2 minus 2x squared minus 10. Alright, so this purple one is our even degreed function, and we can see that in this situation the behavior again is like this, right? It ends up like this. And watch as I do this. If I put a negative leading coefficient on it, now look at the direction that it goes. Right? It now goes down. Whereas if I get rid of this, it's going back up again. Same thing with this one, the cubic. I have that and I can make it go down by doing that. Right? And now it's going the opposite way. Instead of being up down, now it's down up. Okay. Alright, so hopefully that kind of clears up that idea for you guys. For this one, if we just keep increasing degrees, we know how it's going to look like, but we can also tell things about the zeros. So for example, if we're looking at this x to the fourth, let's look at the first one. We had a line. How many zeros are possible? 1. We had a quadratic. How many zeros are possible? 2. We had a cubic. How many zeros are possible? 3. We have a quartic, which has a 4th degree. How many possible zeros are there? It should be 4, right? But in this situation, we only get 2. Watch if I do this. Let's make it plus. Let's go minus 5. Why don't I do this? I'll change this to x. Okay, so for a degree 4 polynomial, I could just do something like this. X plus 1, x plus 4, x plus 7, and then x plus 10. If I multiplied this out, I would get an x to the 4th power, right? How many x's do I have? 1, 2, 3, and 4. If I actually took the time to multiply this out, I would get an x to the 4th plus something, on and on. Now you can see in this example, it shows me all my roots right here, and this is what we're going to talk about, is these roots. Is that you can see them right here at 1, negative 1, 0, negative 4, 0, negative 7, 0, and negative 10, 0. And that comes from these factors right here. From these factors, I can tell that the 0 is always x plus 1 equals 0, so that makes it negative 1. So that's right here. X plus 4 equals 0, well, that makes it negative 4. X plus 7 equals 0, that gives it negative 7. And then x plus 10 equals 0, that's negative 10. Okay, so that's kind of like the idea behind this. And what we're looking at now is, what if I had something like this? Get rid of some of this stuff. Let's go with x plus 1, x plus 1, and x plus 1. Turn this one on. Now, how many roots did I get in this situation? Just 1, right there. Now, when this happens, this causes only 1 0, because if I look at it, all of these zeros are still negative 1, negative 1, negative 1, negative 1. And what the book calls that, and what mathematicians call it, is this is a, I'll type it out here. This is called a 0 of multiplicity 4, right? In this situation, it would be a 0 of multiplicity 4. And you normally say the multiplicity based on how many times it shows up. And you can see it in the book too. Let's pull it up in the book. So if you identify that you have something like this, x minus 3 repeated 3 times, that tells you that x minus 3 is a factor 3 times. The root 3 has a multiplicity of 3. So it would be the root negative 1 has a multiplicity of 4. And that's essentially what they're doing. If you repeat the same factor over, you can say that the root, see how this is the factor is x minus 3, but the actual root is 3. That's because you set x minus 3 equals 0. That gives you that the root is 3. And you say that that root has a multiplicity of 3, because that happens 3 times. And that's important because it kind of like is a way to say that we are looking at something where there's just 1 0 occurring. Now we could do something like this, like let's do minus 3. Okay, now in this situation, I have 1, 2 zeros, and I would have a multiplicity of 3 on the root negative 1, and a multiplicity of 1 on the root 3. Okay, so that's just a way of saying things. So that covers the first part. And I think that shouldn't be too crazy hard for you guys. this will be the second part, and the second part's the hard part. Okay, so let's look at an example here. I pulled this one up, and I should probably write that out. So I'll write that out onto this. Alright, so I wrote this one out, and this is our polynomial, and we want to look up the factors. So the first thing I notice is that I can pull out a 2 out of everything, right? There's a 2 on everything. So I'm going to pull the 2 out, and that's going to give me a factor of 2. So now I'm dealing with 2 times x to the 5th plus 6x to the 4th plus 8x squared, or x to the 3rd, minus 6x squared, and then minus 9x. Alright, there's something else I can pull out here, which would be the x. So I'm going to go ahead and pull that x out from all of it, and I'll get a 2 and an x, so I'll just make that 2x, and there's one of my factors. Or you could say it's 2, like a 2 times the x. So that leaves us with 2x times x to the 4th plus 6x cubed plus 8x squared minus 6x and then minus 9. Okay, from this point, some of you guys might look at this and say, well, it looks like I could group it, but the problem with grouping for this one is it actually won't work out very nicely. I would say 9 out of 10 times, if there's an odd number of things, it's not going to work out really nicely. So instead, what we're going to do is we're going to start guessing with synthetic division. Okay, so I'm going to go ahead and check. I have a good feeling about, let's try 1 as a factor. So let's try 1. Alright, so if I use 1, then I will use that, and then let's see what that gives me. So I have 1x to the 4th, 6x to the 3rd, 8x squared, negative 6x, negative 9. Alright, so that should give me 1, it gives me 1, 7, it gives me 7 again, it gives me 15, it gives me 15 minus 6, that gives me 9, multiply by 1, I get 9, lastly I get 0. So, looks like I got lucky. I picked this, and I ended up actually getting a actual factor. So if this is actually my factor, or if this is the root that works, what is the factor that I used? Well, the factor that I used has to be x minus 1. Okay, so that tells me that part, right? Because I used this. The actual root is 1, right? Because if I plug in 1, I will get 0. Alright, so what am I left with here? This tells me I have positive 9x, x squared, and x to the 3rd. And you know what? I have another good feeling. Maybe we'll try negative 1. So let's try negative 1 for that one. And let's do synthetic division on it. We got 1, 7, 15, 9. And that's going to end up giving me this, which would be 0, so that's 1, negative 1, 6, negative 6, 9, negative 9, 0. Okay, so that's giving me another factor that I have x plus 1. And I know what this is going to leave me with. This leaves me with x squared plus 6x plus 9. And I know I can break this apart into x plus 3 and x plus 3.